The goal of this video is to answer the question, what is a confidence interval? Previously, we have looked at sampling. We learned about sampling in Chapter 1. We know that a simple random sample is the best, and that a convenient sample might invalidate any conclusion that we make. So the goal of inferential statistics is to infer things about the population based on data from the sample. So in Chapter 1, we had our population. We took the sample. Now, what we're going to do is calculate things about the sample and use them to infer things about the population. And that's the meaning of inferential statistics. We know, for example, that the sample mean would be x bar, and the sample proportion, p hat, and the sample variance, s squared, all of these target or provide unbiased estimates of the true population parameters. So this is going to infer that the population variance, and we use the Greek letter for that, and p hat is going to infer the population proportion, which we use p. And x bar is going to infer the population mean, which we use mu. So all of these are unbiased. They give us a very good estimate of what is actually happening in our population. Let's take a look at an example. Here we have the whole population of Massachusetts, and we want to know the mean diastolic blood pressure of all the adults in Massachusetts. I looked on Google. Massachusetts has a population of 6.75 million people. We don't have the time or the resources to screen all of them and figure out what their actual diastolic blood pressure is, and then take that 6.75 million numbers and find the mean. So what we want to do is we want to sample them. And so we take our first sample and we find the mean of that sample. We call this mean, and this would be an x bar, a point estimate. It's one point, one single number that estimates the mean. So maybe it's exactly right, and the target was so exact that the mean of all of Massachusetts for blood pressure is 75. But maybe it's off a bit. So in Chapter 6, we studied repeating this process to create a sampling distribution. And we know that the sample means, all these sample means from tons of them, are normally distributed. So maybe 75 is truly the mean right here in the middle. Or maybe it's on the high side and it's like this number up here and it's off a bit from the true mean. We, in Chapter 6, then found the mean of the sample means, sometimes called the grand mean. And that, the mean of the sample means, truly did target the population mean. So in Chapter 6, what we would have done is we would have taken another sample, found the mean, another sample, found the mean, and then we would have found the mean of those. We're now going to look at a new process, and it's a process that's often used and reported around election time. So typically, we're given the proportion of voters who would vote for a certain candidate, and then we're given a margin of error. So it might be 73% of voters are leaning towards voting for Obama, plus or minus 5%. So we know that it's not exactly 73, but it's close. 73 plus 5 would be 78. 73 minus 5 would be 68. Either way he wins. That's more than 50% of the popular vote. So let's take a look at this concept with this example. And so what we're going to do this time is we're going to take our point estimate, and our case, that's a sample mean. So we have this sample, the mean of 75. And then we're going to add or subtract a margin of error. We'll use big letter E to represent that. And so we're going to calculate this margin of error based on how confident we want to be that we have a range of values that includes the true population mean. Most of the time we'll use 95% as our confidence level, and so we'll calculate the margin of error based on that 95%. And we'll learn how to calculate that later. Right now we're just going to pretend as if we already calculated this and our E value is 4. So our formula here, our mean from our sample, our point estimate is 75, and we'll add the margin of error, which we made up and said is 4. And that gives us a range. So we have a confidence interval, and I'm going to abbreviate that CI, confidence interval, of 71 when we subtract, which is less than the true mean, is less than, and if we add 79. Sometimes the confidence intervals are just given in this notation. So we would say that we are 95% confident that the interval from 71 to 79 millimeters of mercury actually contains the true value of the population mean. So instead of just giving point estimate, we're giving an interval, and we are saying our confidence level that the true mean is in this interval.